I don't know. Good morning. How is everyone today?
Tired.
Tired? Hey, I'm right there with you.
Yeah, I'm tired too.
Right there with you. So let's see, we've got 1, 2, 3, 4, 5, 6, 7. Who are we missing? Keely.
I will be right back. I need to go grab something.
Okay, that's fine. All right, while he's doing that, I'm gonna go ahead and share my screen. And April, it just dawned on me, I saw your message late last night and I did not get back to you yet. So we will talk through those. If you didn't figure them out, we'll go through them.
Okay, thank you.
All righty, so let's see, look at our homework. We had all right, the test was due, so hopefully if you had any trouble uploading or anything, be sure to let me know. I sent everybody, I think most everybody's gotten their test corrections back for test 1. So hopefully if you haven't gotten those back to me, if you could get those back to me this week, that would be fantastic. Then we had pages 132, 133, and 139 and 140. So we'll go ahead and start with 132 and 133. Let me get my.
Jennifer, did I send you my test?
Did you upload it or email it?
I think I uploaded it.
Okay, I'll have to look and see.
No, I have not uploaded it. Yeah, yes, I will. I'll do that after this.
You will send it. Okay, that's fine.
Okay.
That is just fine. Okay, so page 132, I think is where we are starting today. I can get there. Okay, let's see. And 21. Yeah, okay, so we had been, we had 132, 133, numbers 2 through 36 even, so we'll get ready and go through those. All righty, so starting at I said 2 through 36 evens, but we did the beginning of those. So we did 2, 4, 6, and 8. All right, so we're going to start with number 10 on page 132. Number 10 on 132. All right, so number 10, the answer is parallel. Number 12, the answer is skew. Any questions about those? Then we'll move on to number 14. It says name a line parallel to line QR. You could have chosen, it says there, you know, just to write one, there may be more than one answer. So you could have written line UV, you could have written line TS, or you could have written line XW. Any questions on that? Okay. Number 16, name a line skew to line QR. You could have written line TX, you could have written line SW, you could have written line UX, or line VW. And just a reminder, make sure, look at your answers, and when you, if you wrote like the 2 letters, name in the line, make sure you have your line above it with the arrows on top. I want you to get into the habit of making sure you've used the little correct symbols for when you're naming lines. So like if it's a ray, it's just an arrow on one end. If it's a segment, it's just the line with no arrows. If it's a line, it has 2 arrows, that kind of stuff. So just want to get in the habit of writing those, because then if you name like a line on a test or something and you haven't used the right symbol, I may think that you have chosen the wrong answer, whereas you've done the right answer, you just did the wrong symbol. So, all right, so that was 16. And moving on to number 18, applying postulates. It says how many lines can be drawn that fit the description. So number 18, through L, a line through L that is parallel to line JK, and that would only be one. Only one line could be drawn through L. Number 20, tightrope walking. Philippe Petit sometimes uses a long pole to help him balance on a tightrope. Are the rope and the pole at the left intersecting, perpendicular, parallel, or skew? And those are going to be skew. They do not touch, they do not intersect, so they could not be perpendicular. They do not intersect, and since one goes one direction, the other goes another direction, they're not parallel, so those would be skew. Number 22, I have angle 9 and angle 14 are alternate exterior angles. Number 24, angle 11 and angle 12 are alternate interior angles. Number 26, angle 10 and angle 14 are corresponding angles. Any questions on those? All right, moving on down. They give us a box that has Roman numerals and the base 10 values, okay? And so we know that I means 1, V is 5, X is 10, L is 50, M is 1,000. And so, so then it says to write the Roman numeral that consists of the indicated segments, then write the base 10 value for the Roman numeral. For example, base 10 value of XII would be 10 plus 1 plus 1, which is 12. Okay, so on number 28, 2 non-congruent perpendicular segments. Okay, so 2 non-congruent perpendicular segments, if we looked at each of those letters, that would be letter L. Letter L would be perpendicular because they would intersect to form a right angle, and that Roman numeral is 50. Any questions on that? Number 30, 2 intersecting segments that form vertical angles. That would be X, and the value of X is 10. Questions on that? All righty, and then what our last one, we just went through 32, is that right? 36. Okay, so 32, we're talking about escalators here. And it says the steps of an escalator are connected to a chain that runs around a drive wheel, which moves continuously. When a step on an escalator reaches the top, it flips over and goes back down to the bottom. Each step is shaped like a wedge, as shown at the right. On each step, let plane A be the plane that you stand on. So it's talking about if you're standing on plane A. Number 32 says, as each step moves around the escalator, is plane A always parallel to the ground? And that answer is going to be no, because as it goes over that wheel, it's going to be perpendicular at some point. As it's going around, it's going to kind of shift around. So it's not always going to be parallel. And 34 is line L on any step, always parallel to any other step. So when we're comparing step to step, Yes, they are going to be parallel. And 36, as each step moves around the escalator, how many positions are there at which plane A is perpendicular to ground level? And that's going to be those 2 times that it goes where it goes over the wheel and as it comes up from the wheel. So that answer is going to be 2. Any questions on page 132 and 133? All righty, so let's move along to pages 139 and 140, dealing with our proofs and perpendicular lines. All righty, so we had numbers 12 through 16 evens on 139. All right, so we'll go ahead and start there. So you can see that we have our perpendicular lines that form a 90-degree angle. So we can see that we have given the number 60. So the value of x on number 12 is 30 degrees. Number 14, I have perpendicular lines AB, or AB is perpendicular to CB. So I can see that I have angle 1 and angle 2, okay? So if we look at this, what would we know for sure about angles 1 and angle 2? We do not know that they are going to be equal in measure because it did not tell us particularly that this is a segment, that this is an angle bisector. If the direction said, or if the picture told me that this was an angle bisector, to me it looks like an angle bisector, but we can never assume something based on the drawings. We have to go with what they tell us specifically, okay? So they haven't told us that it's a bisector, so the only thing we know for sure is that angle 1 and angle 2 are complementary. The only thing we know for sure is that they could add together to equal 90 degrees, okay? And then number 16, I have H is perpendicular to K. I've got angles 1, 2, and 3. And so when we look at these, we know that angle 3 is going to be a right angle. Now in this situation, we go ahead and say that even though we don't have our square there, because we've got our perpendicular lines, and then we would know that angles 1 and angle 2 are complementary. All right, so that was 12 through 16, and then we moved on to page 140, number 19. So we had a proof here. We had some missing information, and so it says angle 1 and angle 3 are vertical angles. That's the definition of vertical angles. Number 2, the vertical angles theorem. Okay, so my answer for that one, and I'll go ahead and write them in so you can see. We would have for step 2 that angle 1 is congruent to angle 3. Okay, then we move down to number 3 in our statements, and it says that the measure of angle 1 is equal to the measure of angle 3. And so on that one, if 2 angles are congruent, then their measures are going to be equal. Okay, so let's see, congruent angles are equal. So I'll just put little symbols for that. Congruent angles are equal. All righty. And then look at number 4, angle 1 is a right angle. That is in our given. So they kind of swapped it up on us a little bit here. They put the given, and sometimes, especially if in the reasons, if they haven't listed given as step 1, you know it's going to fall somewhere else in the problem. All right, number 5, our reason is the definition of a right angle. So we are looking at Number 4 says angle 1 is a right angle. So step 5 would be that the measure of angle 1 equals 90 degrees. Number 6 is the substitution property of equality. And so we know that we've been comparing, looking at congruent angles 1 and 3. So now what we've got to do is we're going to substitute, and we are going to put that the measure of angle 3 equals 90 degrees. We have substituted 1 and 3. And then our last one, the definition of a right angle. Angle 3 is a right angle. And so you can see that, remember, our to prove is always going to be the last statement. So that comes directly from the top of the, and from the beginning of the problem. Any questions on that? Is everybody starting to feel a little more comfortable with looking at kind of the flow of things and being able to go, okay, if I've started here, I've moved on here, what was it that changed? All righty. Let's go ahead and move on to our next section. We have 3-3 parallel lines and transversals. This is on page 143. You can see that our page is full of green boxes. So you know that this green information is going to be helpful to you to put in your blue folder. And then that way you're not having to flip all around. Hopefully you've started on that. And again, it's not required. It's just something that I thought might be helpful for you. Okay, so on page 143, we start out with parallel lines and transversals. And it says postulate 15, corresponding angles postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we can see that we've got angle 1 and angle 2. And because they are corresponding, then they are congruent. Corresponding angles congruent. All right. And so it says, above this box, it says you are asked to prove theorems 3.5, 3.6, and 3.7 in exercises 27 through 29. So you know that when we get to those activities, we'll be looking at those. Theorem 3.4, alternate interior angles. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Theorem 3.5, consecutive interior angles. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, so look at, when you look at these angles 5 and 6, they are not in corresponding locations. Okay, so we can see that 5 is going to be an obtuse angle, 6 is an acute angle. But what they're telling us is that I know that anytime I see parallel lines cut by a transversal, that those two are going to be supplementary. Theorem 3.6, alternate interior angles. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. I think I said interior, but I meant exterior. And then theorem 3.7, perpendicular transversal. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one. Because they're parallel lines, that means they're going to follow the same path. So if it intersects, if it's a perpendicular line to one, it's going to be perpendicular to the other. Okay. So kind of thinking about these properties of how we use these parallel lines and these transversals. We talked about our alternate interior angles, alternate exterior angles. We've talked about the corresponding positions. We talked about that last week. So now we're just taking it a little step further and saying, hey, if they're in these positions, then we know that they are congruent. And I will tell you that knowing this information and understanding the position of angles and things like that is something that you might see on the ACT one day. These locations, they are assuming that you know this information, so you may be given a diagram and it gives you a bit of information, and you've got to be able to relate it to the other angles in the diagram. And so these are definitely ones that you need to memorize. You need to know that if it's in a corresponding location, that they're going to be congruent. If they are going to be consecutive interior angles, that they're going to be supplementary. That means they can be added together to make 180, and that if a transversal is perpendicular to one parallel line, it will be perpendicular to the other. Alrighty, so now what we're going to do is we're going to move on to page 144, and it says proving the alternate interior angles theorem. So now what we're doing is we're going with each of these and doing proofs with each of those theorems that we just looked at, okay? So it says we have to prove the alternate interior angles theorem. We are given that P is parallel to Q, and we have to prove that angle 1 corresponds with angle 2. So you can see that the first statement is P is parallel to Q, and that's our given information. So going from there, we have that angle 1 corresponds with angle 3, and that's our corresponding angles postulate. Okay, we know that angles 1 and 3 are in the same corresponding locations, therefore they are congruent. I know that 3 is congruent to angle 2 based on our vertical angles theorem. Okay, so our vertical angles theorem tells us that angle 3 and angle 2 are going to be congruent. Therefore, remember that we learned several lessons ago when we talked about the transitive property, that if angle 1 is congruent to angle 3 is congruent to angle 2, then angle 1 is going to be congruent to angle 2. And that's our transitive property of congruence, okay? So remember, what we're looking at here is we're looking at, to be able to figure that one out, is I've been given one angle and we have this as our common angle here, okay? So I can know that it's transitive when I've got different angles, but then I've got this common angle there, okay? So then that way I can take those away and say that angle 1 is congruent. I'm sorry, so I know that based on having those two equal to each other, that I can, what am I trying to say? That I know that it's the transitive property. Okay. Actually, I circled the wrong two. I knew what I was saying, but I circled the wrong stuff. It's this one right here, where these two were in common. So those are the ones that I know that because I have those in common, then I can put those two together. I just wrote it wrong. All right, example 2, using properties of parallel lines. The given is that the measure of angle 5 equals 65 degrees. Find each measure. Tell which postulate or theorem that you use. So letter A, we've got angle 6. It's told us our given is, we've got this here with angle 5. We've got vertical angles here, so we know that they are congruent. So for letter A, the measure of angle 6 is equal to the measure of angle 5, and that they're both going to equal 65 degrees. Okay. Letter B, the measure of angle 7. So now I'm comparing angle 7 to angle 5. And so now I'm looking at these two right here. Okay. I've got these two angles together make a linear pair. We know that they are supplementary because they make a straight line. Therefore, we know that the total is 180 degrees. So if we know the total is 180 degrees, I can subtract that measure of angle 5, which is 65 degrees. And I find that angle 7 is 115 degrees. The measure of angle 8, now I've got to compare to angle 5. Okay, so think about those. Those are our corresponding angles. They are in the same location. One is interior, one is exterior, but they're corresponding. And so we've talked about how corresponding angles are equal to one another. Therefore, we know that the measure of angle 8 is also going to be 65 degrees. And then letter D, we're looking at the measure of angle 5 compared to angle 9. And we know that we've already looked at angle 7. Angles 9 and 7 are going to be alternate exterior angles. And in the previous letter B, we found that angle 7 was 115 degrees. Therefore, angle 9 is 115 degrees because they are congruent. Any questions about that so far? The main thing is being able, each time you look at parallel lines cut by a transversal, again, just kind of going through, okay, I see these angles, and going ahead and making the connections before you even look at a problem. Once you've already made those connections by looking at them, then it's going to be a lot easier to be able to go ahead and answer the questions that you're given. So that's what we're going to do, is we're going to take a look here in example 3. So it says botany, and it's talking about leaves, and we can see how sometimes it looks like we've got these leaves that have their veins, or kind of like the parallel lines, and then the vein that runs down the middle would be like the transversal. But it says some plants are classified by the arrangement of the veins in their leaves. In the diagram of the leaf, J is parallel to K, so what is the measure of angle 1? So remember, we've talked about how right here, 120 would correspond with our, we've got our corresponding angles. So if we know that this would be 120, then we know that these two are supplementary. So we would just subtract 180 minus 120 and find that angle 1 is 60 degrees. All righty, so moving along. Please stop me if y'all have questions. If I'm going too fast and not explaining enough, please let me know.
Wait, so on example 3, we're trying to get to 180 degrees?
Well, remember, so we've got a straight line here. Okay, so we've got this straight line right here. I'm sorry, duh, wrong one. Yeah, we've got this straight line right here, okay? We know that this angle is 120 degrees. So because of corresponding angles, that means that this angle will also be 120 degrees. So if I'm trying to find the measure of angle 1, I know that this right here is 180 degrees. So I have 180 minus 120 is 60.
Okay, thank you.
Uh-huh. All righty, properties of special pairs of angles. All right, so it says use properties of parallel lines to find the value of X. So like I said, it's the kind of thing where what I want to do when I first start looking at my diagram is I want to go ahead and start looking at what I know from the problem. And I can go ahead and look at this and say, hey, I've got 125 here, corresponding angle here is 4. Okay, so that means that if angle 4 is going to be equal to 125 degrees. Now, when I look at these two angles right here, how do I want to do that? Let me highlight a different color. If I'm looking at this angle, ooh, that's way too much. We'll just do this. Give me a blue. If I'm looking at this angle here and this angle here, again, I have a linear pair. So I know that linear pairs add together, they're supplementary, equal 180. So I can look at this and automatically know that if I add this angle to this angle, it's going to equal 180 degrees. So I've been able to go ahead and break down this diagram before I even look at my questions. Okay, so that's what I want you to start getting into the habit of, is look at your diagram, figure out what do you know based on all these theorems and postulates that we've learned. Go ahead and do that, and then come over here and it's going to make answering the questions a whole lot easier. Okay, so we found, again, measure of angle 4 is equal to 125 degrees. We already figured that out by looking at our diagram. So then we already looked at that we would need to add the measure of angle 4, which is 125 degrees, plus x plus 15 equals 180. Combine like terms, so I'm going to end up with 125 and 15 will be 140, plus x. Goodness gracious, I'm writing backwards today. I am just all kinds of messed up. Plus x equals 180. Subtract 140 from each side. So x is equal to 40 degrees. Okay. Questions on that? I think a lot of times when you see algebra incorporated into our geometry problems, I think a lot of times y'all kind of go, oh, I don't know how to do that. And you do. All we've got to look at is understanding that, okay, am I going to need to add these two together to equal something? Am I given my total and I have to take away a part to find the other part? That's all we're doing with all of these. Or am I setting something equal to something else based on the position in the diagram?
Where did you get 140?
Where did I get 140? Because I added, so when I got to this step right here,
Oh, I get it.
125 plus 15, I had to combine like terms.
Yes, ma'am.
All righty. Example 5, estimating Earth's circumference. Eratosthenes was a Greek scholar. Over 2,000 years ago, he estimated Earth's circumference by using the fact that the sun's rays are parallel. Eratosthenes chose a day when the sun shone exactly down a vertical well in Syene at noon. On that day, he measured the angle of the sun's rays made with a vertical stick in Alexandria at noon. And so he discovered, when we look at the drawing, okay, now obviously it is not drawn to scale. I love that they put that disclaimer there, that they could not draw the Earth to scale. It's a good thing. That'd be an awfully big book. So it says the measure of angle 2. When we're looking at these, it shows that it's 1/50th of a circle, okay? And so basically, it says, so you can see where we have our parallel lines. So we have L1 and L2 is what they're naming them. So we have the stick and the well. And so we know that the measure of angle 2, where the shadow and the stick make an angle, is going to be the same as where our well and we would have our well and our other angle. But then we can also look at where we have that center of the Earth measure, and we can see this angle coming in here, okay? And so by using properties of parallel lines, he knew that the measure of angle 1 is equal to the measure of angle 2. So he reasoned that the measure of angle 1 was approximately 1/50th of a circle. At the time, the distance from Syene to Alexandria was believed to be 575 miles. So he said, okay, a 1/50th of a circle is equal to 575 miles divided by the Earth's circumference. Okay, so he set up a proportion here. Okay, so basically he said that 1/50 is equal to 575 over x. Okay, so remember doing proportions in algebra. You can set it up where you have your equation is equal to another, a fraction is equal to another fraction, and you let a variable be your unknown. So with proportions, when I have that equal sign, I know I can cross multiply. So I'm going to have x times 1, which is x, is equal to 50 times 575. And that's what they did right here. They've got the 50 times 575. So they found that it was approximately 29,000 miles. Okay. So it says, how did Eratosthenes know that the measure of angle 1 is equal to the measure of angle 2? So let's look at this. And it says, because the sun's rays are parallel, angles 1 and angle 2 are alternate interior angles. So if we look at this, let me erase this real quick. Okay, remember that this line, if it extended, and obviously these are not going to be exactly right, if those lines extended out, this right here is our transversal, okay? And so when we see, when we've got the measure of angle 2 right here, those are going to be alternate interior angles, okay? And so we know that alternate interior angles are congruent, so angle 2 and angle 1 are equal to each other, okay? So again, we have to understand when we're talking about parallel lines that they can extend out indefinitely, that they would continue going, and that transversal would continue going as well. All right, so we're going to move on to our guided practice, and it says, sketch 2 parallel lines cut by a transversal. Label a pair of consecutive interior angles. So it's the kind of thing where when you're sketching these things out, you know, your parallel lines could go like that, and you could have a transversal like that. You could have parallel lines like that, and your transversal could go that way. You know, it really, there's no way that you can write it differently that you're going to end up having different measures of angles. Okay, 2 parallel lines cut by transversal, doesn't matter which way it's going, doesn't matter if it's vertical or horizontal, your angles are all still going to follow the theorems that we've talked about. Okay, so it says label a pair of consecutive interior angles. All right, so let's take a look at these. Consecutive interior angles. Excuse me. All right, so when we look at these, remember interior is going to mean that it's inside my my parallel lines. Interior means inside those lines, so that's talking about this area here, okay? So we're looking in there, we're looking at consecutive interior angles. So what would a couple of those angles be? Anybody got anything?
9 and 8.
Okay, so let's think about consecutive interior angles. Okay, what is our rule about consecutive interior angles? That what they add together to make what?
180.
180, yeah. So, let me make sure. Okay, actually, those are just going to be supplementary angles. To be consecutive interior, they would need to be these two. Okay, they would need to run along the same side of the transversal. Okay, so 7 and 9 or 6 and 8. Okay. So, and then concept check says in the figure at the right, J is parallel to K. How many angle measures must be given in order to find the measure of every angle? So let's think through this for a minute. In this drawing over here, how many measures would I need to know to figure out everything? Let's pretend for a minute. What if I said this was 130 degrees? What other angles would equal 130 degrees?
10.
I'm sorry?
10.
10 would be 130 degrees. What else will be 130 degrees?
6 and
Angle 9.
9 would be 130 degrees. What else would be 130?
Angle 6.
Angle 6. Okay. By one number, we've been able to figure those out. Could I figure out what angle 4 is, knowing that angle 5 is 130? What's angle 4 going to be? 50 degrees. So that means 7 is 50 degrees, 8 is 50 degrees, and 11 is 50 degrees. If I know one measure, if I just know one, I can figure them all out, okay? By knowing my rules, by knowing those theorems that we've talked about corresponding angles, about vertical angles, about supplementary angles, all that, I mean, all of that. If I just have one measure, I can figure them all out. Okay, so now we need to state the postulate or theorem that justifies the statement. So we've got the drawing to the right. We have angles 1, 2, 3, 4, 5, 6, 7, 8. So number 3 says that I have angle 2 is congruent to angle 7. So I'm going to look at their positioning. And so what can I tell immediately about angles 2 and 7? They are on the outside of my perpendicular lines, right? And so outside is exterior. And then they're on opposite sides of the line. Okay, I've got one to the right and one to the left, so that means that they're alternate. So it's going to be the alternate exterior angles theorem. Okay, alternate exterior angles theorem. Let's look at number 4. 4 says angle 4 is congruent to angle 5. It's a little bit similar here. But the main
alternate
difference is,
interior angles.
yeah, alternate interior angles. We can see again that they're on opposite sides of my transversal. So we know that they're alternate, but then they're inside my parallel lines. So they're alternate interior angles. Good job. Okay. Let's look at, let's look at number 5. The measure of angle 3 plus the measure of angle 5 equals 180 degrees. What was that theorem called? If you need to, you can flip back to page 142 or 143.
Consecutive interior angle.
Good, consecutive interior angles theorem. Good job. And then finally, angle 2 is congruent to angle 6. So 2 and 6. When I look at that, I see that they're both on the same side of the transversal, so I know that it's not going to be alternate in anything.
Consecutive exterior angles?
Actually, we don't have to call them interior or exterior because actually 6 is interior and 2 is exterior. So we're not going to, there's just going to be corresponding angles. Okay, corresponding angles is all we're going to call that one. All right, number 7 says in the diagram of the feather below, look at that, this close-up of a feather. Lines P and Q are parallel. What is the value of X? How can we figure out what the value of X is going to be? Think about what we just looked at with angle 2 and 6.
Is it 47?
Those are corresponding angles, okay?
133.
It's going to be 133. They're corresponding angles, so they're going to be the same, okay? So just like up here, when we looked at angles 2 and 6, if I were just to flip it on its side, kind of, I've got the same situation here in this drawing, where I've got 133 is corresponding to angle X, so it is also 133 degrees, okay? So again, what I encourage you to do is as you start working through these, look at the diagram first. I want you to think through what you know about all of these different angles, and then I think you're going to find that it's going to be super easy to answer them, okay? So we'll go ahead and kind of look through these real quick. We will do let's do 8 through 26 evens. So we have 8 through 26 evens. I want you to do number 27 though, the proof. And fill in those gaps.
Wait, 8 through what?
8 through 26 evens. Then number 27. That is all on pages, let's see, does it start? Yeah, pages 146 to 147. Then on page 148, I want you to do number 30. And on page 149, let's look at that mixed review real quick. I want you to do 34 through 44 evens.
Wait, on page 148, what are we doing? Oh, 30. Never mind. Sorry.
Okay, so pages 146, 147, 8 through 26 evens, and number 27. Page 148 to 149. 148, I want you to do number 30, 149, 34 through 44 evens. I'll write that on my little sheet. And this goes along with section 3.3. Make sure I've got that right. Yeah, 3.3. Parallel lines and transversals. Page 146 to 147, 8 through 26 evens. And then number 27, page 148, number 30, page 149, numbers 34 through 44 evens. All righty, let's take a look at our time. It is 9:22. So why don't we go ahead and we'll just take our break a little bit early today. Before we dive into another section, we'll go ahead and just take a break and come back in about 5-6 minutes. Okay. All righty, we'll get ready to start back. For all my football friends, I just saw have y'all seen the movie Brian Song? It's a very old movie, but about Brian Piccolo that had cancer and his best friend Gail Sayers. And Gail Sayers passed away. He was like I think a Hall of Famer that played for the Chicago Bears. That's a great movie if you haven't seen it, by the way, for anybody, football or not. But anyway, sad. Okay, let's come back. So we're going to move along to section 3.4. I know y'all have come to love the word proof and proving as much as I did when I was taking geometry in high school. My hope is that like proofs to me, again, it was that kind of thing where it was just magic. Like you just happened to know, like I could not see any logical connection between one step or the other. So my hope is that from me knowing the struggles that I had with geometry when I was in school, that I can find a way to help you guys try to make the connections. So basically, to really be able to get proofs, not only do you have to know your postulates and theorems, I mean, and that's why I was saying to me it would be helpful to have your blue folder to write all these out, to have one page to flip back to, because just like right now, you know, flipping back between, we've just seen brand new ones on page 143. We picked up one postulate and 4 theorems there. And then on page 150, we've got another postulate and 3 theorems. So we've got 2 postulates and 7 theorems that we're adding to all this information. So instead of having to flip through your book and find these things when you're doing a proof or when you're needing to look to the exact way to write it or the relationship or whatever, having these all together in one place, kind of your arsenal, if you will, you've got a place to go to pull these things and to be able to look. You may think, oh, it's going to be this one, but then when you see, like if you're writing what the postulate is and the name of it, write the description. It doesn't have to be word for word, but just give a brief description so you know. But the key is going to be write that diagram too, and that's going to help you to be able to visualize it and to see it. So hopefully these are going to, you know, they may not make 100% sense to you right from the beginning, but as we go through, hopefully you're starting to see the link and the connection between them all. All right, so, and again, it's the kind of thing where I was like, prove that they're parallel. Well, by golly, you can look at them and see that they're parallel. Why do I have to prove that they're parallel? Well, we just have to. That's just what you do. Again, this is helping us for reasoning skills. It's not necessarily nobody, and if they do, come let me know. Nobody's going to come up to you on the streets one day when you are a grown up and say, hey, I'll give you $1 million if you can prove that 2 lines are parallel. Like I said, you know, if they do, let me know. That would be awesome. But I don't think that's ever going to happen. Now, obviously, if you get into some field of work where you're doing maybe architecture or you're doing some of these other, you know, some engineering, some different areas like this, all of these things are going to come into play. They're not necessarily going to come into play as proving that 2 lines are parallel, but your knowledge and being able to reason through parallel lines, relationships of angles, things like that, they're all going to come into play with that. So, all right, so it says goal 1, proving lines are parallel. To use theorems you learned in lesson 3.3, you must first know that 2 lines are parallel. You can use the following postulate and theorems to prove that 2 lines are parallel. So postulate 16 says corresponding angles converse. If 2 lines are cut by transversal so that corresponding angles are congruent, then the lines are parallel. So now we're kind of doing the flip-flop. Earlier, we said that if the lines are parallel and they're cut by transversal, then the angles are congruent. Now we're just flip-flopping it and saying if the angles are congruent, then we know we have 2 parallel lines, okay? Says the following theorems are converses of those in lesson 3.3. Remember, now we're going back to chapter 1, talking about converse, inverse, contrapositive. Remember, converse is the flip-flop. So that's all we're doing here, is all of these are going to be the flip-flops of what we just looked at. Theorem 3.8, alternate interior angles converse. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Theorem 3.9, consecutive interior angles converse. If two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. Theorem 3.10, alternate exterior angles converse. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Okay, so we can use the parallel lines to prove angle relationships, and we can use angle relationships to prove parallel lines. So that's what we're looking at here. Angle 1, proof of alternate interior angles converse. So it says prove the alternate interior angles converse. All right, we look at our diagram first. I'm going to kind of dissect it for a minute. We can see that we have angle 3 up in the top location. We can look at this and know that angle 3 and angle 1 are going to be corresponding. Okay. We can also look at this and see based on, and then it gives us these little symbols, the little angle arc. We can see that angle 2 and angle 1, we know that they're alternate interior because they're inside those two parallel lines, but they're on the opposite side of the transversal. So opposite side of the transversal tells me they're alternate. In between the two parallel lines means they're interior. Okay. So we've looked at our diagram, and now it says we want to prove that angle 1, the given is that angle 1 corresponds with angle 2. And we want to prove that M is parallel to N. So here we've started with our given. Angle 1 is congruent to angle 2. Then we're going to use the vertical angles theorem. Right here, that angle 2 is congruent to angle 3. Number 3, transitive property of congruence, because you can see that we started with angle 1 is congruent to angle 2. So if angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3, and that is our transitive property. Therefore, if angle 1 is congruent to angle 3, then M is parallel to N, and that is our to prove. So that is the corresponding angles converse theorem that we just looked at. The corresponding angles postulate. Okay. So it says when you prove a theorem, you may use only earlier results. For example, to prove theorem 3.9, you may use theorem 3.8 and postulate 16, but you may not use theorem 3.9 itself or theorem 3.10. So basically, it's just saying that there are different theorems that you may end up using. You may use some that are from earlier sections, or they may be from each section. Proof of the consecutive interior angles converse. All right, so again, we've got our diagram. I can see that 6 and 4 would be our alternate interior. We can see that 5 and 4 are going to be consecutive interiors. We can see that 5 and 6 would be supplementary, would be linear pairs. Okay, so there's all kinds of things that we can see here. And our given 4 and 5 are supplementary. Okay, so we know supplementary means they add together to make 180. This time they used a paragraph proof instead of our statements and reasons. So following the paragraph proof, it says you are given that angle 4 and angle 5 are supplementary. By the linear pair postulate, angle 5 and 6 are also supplementary because they form a linear pair. By the congruent supplements theorem, it follows that angle 4 is congruent to angle 6. Therefore, the alternate interior angle converse, G and H, are parallel. Example 3. Applying the consecutive interiors angle converse. Okay, so again, we're looking at our diagram. We know that when we look at this relationship, consecutive interior angles means that they're on the same side of the transversal. but I can see that I've got an acute angle and I've got an obtuse angle. And I know that if I add them together, they're going to equal 180. So before I even look at what my question asks or anything, I know that I can have 4x plus x, that's my x, equals 180. I would simplify that, and 4x plus x is going to be 5x equals 180. Divide by 5, divide by 5. X is going to be, what is that going to be? Whoop, 35? 36. Okay. So then I can come over here and it says lines J and K will be parallel if the marked angles are supplementary. Same thing over here. We didn't even have to look to see. We just automatically can look at that and know. Okay. So when I see solving for X and these different things, I'm having to look at what is the relationship between the angles. Do I add them together to make 180? Do I take 180 and subtract? What is my relationship here? Goal 2, using the parallel converses. Okay. Example 4, using the corresponding angles converse. And it says sailing. If two boats sail at a 45-degree angle to the wind as shown, and the wind is constant, will their paths ever cross? Okay, so if they're sailing at a 45-degree angle, then they're not going to cross. Okay, because that 45, if they're consistently going out and this one is parallel to that one, they are good. So it says, because corresponding angles are congruent, the boat's paths are parallel. Parallel lines do not intersect, so the boat's paths will not cross. All right. Example 5, identifying parallel lines. Decide which rays are parallel. Okay, it says, is ray EB parallel to HD? So let's take a look at this. Let's highlight them. So I'm looking at EB, and is it parallel to HD? So look at that for a minute. What is my angle measurement there? My angle measurement here is 58 degrees and my other one is 61 degrees. Okay, so if one is 58 and one is 61, then they are not going to be parallel. Look at letter B. Is EA parallel to HC? So on this one, we're looking at EA, which is 62 degrees, HC, which is going to be 59 degrees. And so we can look at those. We've got 62 degrees plus 58 degrees is 120 degrees. And so it says they are AEH. Let's see. Let me unhighlight these real quick so I can highlight that. Okay, so like we said in the first one, EB and HD, we can see that because one's 58 degrees and one's 61 degrees, that they are not parallel, but they are corresponding angles. Okay, so if we were to look at this one continuing out and this one continuing out, I've got the different degree measures. Okay. Letter B is EA parallel to HC. EA is 62 degrees, HC is 58 degrees. So that means if we look at AEH there, notice I would add together 62 and 58. Then if I were to look at DHG, where's my D? No, I'm sorry, CHG. CHG. Looking at that one, again, I would add together those two angles. 59 and 61 also equal 120. So I can see that when I add the two angles together, they both equal 120, so they're congruent corresponding angles. Okay. So because those are congruent corresponding angles, when I look at the angles as a whole as 120 degrees, then I could see that this line and this line are going to be parallel because each of these both equal 120 degrees. And that's it on this section, okay? So let's look at our guided practice. What are parallel lines? Okay, so parallel lines, we know that there are going to be two lines that never intersect. Right, the converse of theorem 3.8 is the converse true. So let's flip back and look at 3.8. 3.8 says if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. So the converse of that, remember the flip-flop, the theorem is P then Q. So now we're going to flip it and do if Q then P. So we would say if the lines are parallel, then the two lines are cut by a transversal so that alternate interior angles are congruent. And so when we look at that and we see that it is a true statement, okay? So remember, then we could say that these are biconditional statements, right? Because if it's, you know, if P then Q and if Q then P, then we've got biconditional statements there. Let's look at number 3. Number 3 says, can you prove that lines P and Q are parallel? If so, describe how. Okay, so let's look at number 3. They have identified two angles with our little angle measurement, the little arcs, to tell us that this angle is equal to this angle. What is the relationship of these two angle placements? They're going to be on the outside of my parallel lines, and they're on opposite sides of my transversal. So they're going to be alternate exterior angles. They have the same measure. So my lines are parallel because the alternate exterior angles converse tells me that. Let's look at number 4. Number 4 says I have got these two angles are going to be congruent. Let's think about the relationship of our two angles. We've got vertical angles. Well, just because these are vertical angles and these would be vertical angles doesn't necessarily mean that they're the same angle measurements. The only way I could tell if these are going to be parallel lines would be based on our angle measurements here and here, or if I had these two telling that they were congruent. So based on the information that I know, I can't say that they're going to be that P and Q would be parallel because this angle may not measure this angle here. I don't know. The information they gave me doesn't tell me that those would be related in any way. Number 5. Number 5. Okay, so I have this angle here and this angle here. Well, let's take a look at that. For it to be alternate exterior, I would have to have here and here. I don't have that, so I can't prove that. for it to be corresponding, I would have to have here and here. I don't have that. So because I can't show any of these congruent angle relationships, then I cannot prove that P and Q are parallel. Does everybody get what we're doing? Is everybody okay with that? Is everybody following? Okay,
Yes, ma'am.
good. I just wanted to make sure I'm making sense. All right, let's look at number 6. Number 6, I see that I've got this angle here, this angle here. I have alternate interior angles. They're both 62 degrees. So yes, alternate interior angles converse, converse. We've got that theorem, and so we can prove that P and Q are parallel. Number 7, 105 here, 105 here. Corresponding angles are congruent. They both have the same measure, so P and Q are going to be parallel. Number 123. Number 8, I've got 123 here, 57 here. 123 plus 57, 10 carry my 1, they equal 180. So I have consecutive interior angles, so they are parallel. Let's look at number 9. Find the value of X that makes J parallel to K. Okay, so remember, first I have to figure out what is the relationship here. My relationship is going to be that consecutive interior angles converse. Okay, so that means that 3x plus x, whoop, go away, equals 180. So 4x equals 180. Divide by 4, divide by 4. X is going to equal 45 degrees. Okay, so that means this one is 45 degrees. So if I had to find the measure of this one, I'm going to have to do 45 times 3. And that would be 135 degrees. Okay, so always check and make sure the directions didn't tell me that I had to solve to tell the measure of each angle. Okay, all it says is which postulate or theorem supports that, and that's the consecutive interior. It did say find the value of X, but it didn't say that I had to find the other measure. Okay. Okay, so for this section, we're on page 153. Whoop. Page 153, numbers 10 through 18 evens. Look at our next page. We have page 154. Let's do 20 through 28 evens. And that will be it. Okay. I don't want to push too much in. Doing 2 sections in a day is plenty. So we're done with our sections for today. So you can either stay logged in and start working on your work and be able to ask questions if you need help, or you can just say, you know what, I am done with geometry for the morning and I want to log out and I'm going to do my homework later. It is totally up to you what you want to do with this time. It is 9:51, so usually we don't get out until what, 10:15. So we're just gonna, either end a little early or you can stay logged in and do your work. I'll stay logged in, so if you want to stay, I'm here. If not, then I will see you tomorrow morning.
I think I'm gonna go.
Okay, I understand.
Bye. I'll see you
If
tomorrow.
you're leaving, I'll see y'all tomorrow.
Thank
Can you
you.
help me with that homework?
That's all your homework. Thank you.
Can you help me with that homework?
Yes, absolutely. What page was that from?
Let me see. 106. I mean, the first one was on 106. Number 16.
Okay, so this was the one where we were unscrambling. It told us the reasons on the other side. It looks like they've got them cut out on little strips of paper. And actually, I'll bring my page up real quick. Let me go back to 106. Whoops, on here. Here we go. Okay. So here, they gave us the different reasons that are all mixed up. And so what we've got to do is unscramble them, okay? So if we look at number 1, it gave us these statements. UV is congruent to XY. VW is congruent to WX. WX is congruent to YZ, okay? And I can look, and that's all stated right here. So what should be reason number 1?
Oh, someone's trying to call me. No, okay. Sorry.
That's okay.
Reason number 1.
So look at all of our reasons on the right-hand side.
Let's see. Then it would be, trying to think back.
What does it say right before it where I circled it at the top?
Given? Oh, so
given.
it's given.
Yeah. So this reasons number 1 would be the given. Okay. Now when we look at this, our next step says that VW is congruent to YZ. Okay, let's look at our reasons. Transitive property, so stop and think about that. Transitive property says that if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then I can understand that angle 1 and 3 are congruent. That's not what it's telling me here. Addition property of equality tells me that if I add things together, it equals the larger thing. That's not what it's telling me here. Definition of congruent statements. Remember, we've talked about how if we have a definition of something, we're going to have an equal sign. So I don't have an equal sign here. Move on down. I've got the segment addition postulate. Nope.
Is it substitution?
And then
No, never mind. It's not substitution.
Okay, sorry, look, what I didn't do is say, let's look back at number 1 and see how these two are different, okay? So I've got UV is equal to XY, I'm sorry, UV corresponds to XY. And so I can see in my second one, I've got XY. No, I don't, that's YZ, good grief. VW is congruent to WX. WX is congruent to YZ, okay? So in here, I've got VW and YZ, okay? These are the things in common. So then I was able to link these two together. So what property did I talk about just a minute ago, that if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then 1 is congruent to 3. So like if I number these, if I said this was 1 and this is 2 and this is 2 and this is 3, because they're both equal to 2, then 1 is equal to 3. So that's the transitive property.
Yeah, that's what it says.
Yeah, that's the transitive property. So for number 2, it's going to be transitive property. So I'm going to go ahead and number that one. All right. So now we've gone from 2 and we're trying to look at, okay, what we've done here. So I have UV equals XY and VW equals YZ. And remember, I talked about how if I have my equal sign, I know I'm dealing with definitions. Okay, so I've got 2 options here of definitions. And notice that I've got definition of congruent segments, and they're both that. Okay, this one says the exact same thing as this one. So I could pick either of those for number 3.
Okay.
Now I've got UV plus VW equals XY plus YZ. So look at that. What am I doing? If I have plus signs, what operation am I using?
Addition.
Addition. And there's an equal sign in between. So what is that going to be?
Addition property of equality.
Good. And then I've got if UV plus VW, so no, whoops. Notice I've got UV plus VW equals UW. So I've gone smaller segment plus smaller segment equals big segment. And XY plus YZ, smaller segment plus smaller segment equals larger segment. I'm adding, and I'm adding segments. What is that one going to be?
Segment addition.
Good. Segment addition postulate would be number 5. All right, then we go to 6. UW is equal to XZ.
Then it's the, goodness, I can't think right now. Other definition of congruent segment.
Actually, and I said something that's incorrect. I've been trying to say go based on the equal sign, and that's not. It can be either way, because looking at this one, I've messed that up. Notice when I go from 5 to 6, I have got that this is equal to this. So basically, I have been able to substitute UV plus VW for just UW. And I've substituted XY plus YZ for XZ. So 6 is actually going to be the substitution property. And so 7 is a definition. I'm sorry, I need to get out of the habit of saying that. It just happens to be that usually we see that equal sign and we've got the definitions, but so 6 is substitution and 7 is definition. And then number 18, I had given y'all some information about this, and I think I had erased it when we went through it in class. So basically in this one, we have the given is NK is congruent to NL, and NK equals 13. So that's what I've written over here. So I have S is for my statements and R is for my reasons. So the first one is my given. Then I went ahead and said NK is equal to NL, and that's our definition of congruent segments. And then because these are equal to each other, I was able to substitute, because in my given it said NK was equal to 13. So here I substituted 13 for NK and said that NL is equal to 13, so that's substitution. Okay.
Goodness, throat. I think the next one was like 18 on page 113.
On page 113?
Yes.
All right. Okay, so in this one, this whole from here down, this is all dealing with number 18.
Mm.
Okay, this whole thing. So we have, it says copy and complete the proof of the congruent complements theorem. So we have our given and what we are trying to prove, and we have the pictures of the angles that we're using. Okay, so we have angle 1 and angle 2, angle 3 and angle 4. So if we look at our proof, it says angle 1 and angle 2 are complements, angle 3 and angle 4 are complements, angle 2 is congruent to angle 4. So what is our reason number 1 here? Most of the times, what is our reason for statement 1 in most proofs?
Given.
The given. Good. Okay. So then for step 2, notice it says the definition, the reason is the definition of complementary angles. Okay. So in number 2 there, look at what, so and it shows, I'm going to have 2 answers here. Okay, so based on our looking from step 1, it says 1 and 2 are complements, 3 and 4 are complements. So for right here, what would I put when I say that there are complements? What does that mean that if I add them together, what do they equal? Complementary angles equal what?
180.
No, that's supplementary.
That's 90. It's
90. Good. So here, I've just said in statement 1 that 1 and 2 are complementary. So angle 1 plus angle 2 equals 90 degrees. That's the first blank. And then here, I would write angle 3 and angle 4. Or I'm sorry, angle, not and, plus. Goodness, hold on. Angle 3 plus angle 4 equals 90 degrees. Okay, now let's look from 2 to 3. It says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And that's the transitive property of equality, because what they've done is they've said that if angle 1 plus angle 2 equals 90 and 3 and 4 equals 90, then I can put the measure of angle 1 plus 2 equals the measure of 3 plus 4. So now looking at step 4, the measure of angle 2 equals the measure of angle 4. The measure of angle 2 equals the measure of angle 4. So let's look at our picture. Look back at our given also. And what did we see from our given about angle 2 and angle 4?
That they are complementary.
They're congruent.
Yeah, congruent.
We can see that they're symbols. So if I have that the measure of angle 2 is equal to the measure of angle 4, then this is going to be the definition of congruent angles. And then to get from 4 to 5, I have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. So basically, let's see, 2 to 4. So I've said that 1 plus this one. Oh, hold on a second. Okay, if we look at number 3, let me erase what I've highlighted or what I've underlined so you can see it clearly. Okay. When we look at step 3, we're going to have to look at 3 and 4 to figure out 5. Okay. So notice we said the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Okay. So we found that the measure of angle 2 here is equal to the measure of angle 4. Okay, so we know that those two are equal to each other. So instead of putting 1 and 2 and 3 and 4, they've done 1 and 2 and 3 and 2. So what is different between these two?
The 2 at the end.
Okay, I've got a 4 and 1 and a 2 at the end, but what did we learn in step 4?
That they're congruent.
What is it? What's my sign between them in step 4?
Oh, equal sign.
They're
But
equal. So if I showed in step 4 that they were equal, and in step 5 I used 2 instead of 4, I have substituted. So it's the substitution property. Okay, so 5 is the substitution property of equality. Now to get from 5 to 6. Okay, I'm going to erase so we can look at it clearly without all these marks on it. Okay, now we're going from 5 to 6, so I'm looking at what's different. I've got measure of angle 1, measure of angle 1. I've got equals the measure of angle 3 and equals the measure of angle 3. What is missing in step 6 that is there in step 5?
2.
The measure of angle 2. So basically what they did is they said, okay, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And they've subtracted the measure of angle 2 from each side. And they've ended up with the measure of angle 1 equals the measure of angle 3. So because they subtracted the measure of angle 2 from each side, what property is that?
Subtraction property.
The subtraction property of equality. Good. So I'm going to put sub prop of with an equal sign. And then finally it says the definition of congruent angles. And remember, our last step is typically what they've told me to prove from the beginning. So what would statement number 7 be?
Not talk. Measure 1 is, well, angle, whatever it's called. Yeah, is congruent. I get congruent
You're
and
good.
complementary things mixed up.
Yeah.
They're whatever till 3. I can't say
Good.
it.
Angle 1 is congruent to angle 3. The time you say measure of is if it has the M in front of the angle sign. Okay, so the M in front means measure of the angle. If it's just the angle, you would say angle 1, angle 2, and then our little sign between complementary, congruent, all of our different words. It's hard to remember and keep them all straight, but it's going to be congruent. Did you have any other ones?
I don't think so.
Okay. Well, very good, very good.
Yeah, that was it.
All righty. Well, you need help with anything else?
I don't think so.
Okay. Well, very good. How about you, Clara Jane? How's it going?
It's going okay. I was doing my homework that you sent out for today.
Good.
I'm kind of stuck on number 14 on page 146.
Okay. So let's flip to that real quick. 146. Number 14. Okay, so let's see. Let me get my page there. Whoop. Okay, so look at your diagram. What do you know about your diagram?
We know that X and Y are on the inside.
Okay, and what is that relationship called? What did we learn about that?
I think it's consecutive interior angle.
Uh-huh. So what does that mean?
That they're both on the inside of the rays.
They are. And actually, here it is. I've got it pulled up real quick right here on page 143. So if they're consecutive interior, what does that mean? They are both on the inside.
There are two parallel lines. They're cut by a transversal.
Mm-hmm. And so look at the screen real quick.
So they're
What else?
supplementary.
Good. So what does that mean?
They equal 180.
They equal 180. So I know that x plus y equals 180. Okay. So now let me get to 146. So
Did
if
you
I know
say
that x,
is it x plus y equals 180?
yes. So I know
Okay.
that x plus y equals 180. How
Okay.
can I figure out which one, what either x or y measures?
Well, we know that that outside angle is 65.
Good. So how can we use that information?
We can take 180 and subtract it from 65 to be
Okay.
115.
Okay. So what does that mean y is?
So that would mean x is 65 and y is
Good.
115.
Awesome.
Okay.
You got it. You got it. So remember, so 65 and x are corresponding angles. So I know that x is 65. So then to find y, you just subtract from 180. Good
Okay.
job. Great. Any other questions?
On number 12, I think I figured it out.
Okay.
But I just don't know what formula goes with it.
Okay. So look at this one, thinking about what we just did. What do you notice about the relationships here?
We have
First of all, what's our relationship with 109 and x?
they are both consecutive interior angles,
Okay. So how does that mean I can find the measure of x?
which means they're supplementary.
Mm-hmm. So how can I find x?
Take 180 and
Yeah.
subtract it from 109.
We'll do 180 minus 109. And what is that going to equal?
71.
All righty. So if
And-
x is 71. Now, what is the relationship with 109 and y? What kind of angles are those?
Which angles?
109 and y?
Oh, those are vertical angles, which means they're complementary.
Not complementary, they're congruent.
Congruent.
So what does that mean? What does that mean y equals?
109.
Good. Yeah,
Sorry, I had written 71, so I was kind of confused.
that's okay. Yeah. So because 109 and y are vertical, they're going to be equal to each other. They're congruent. 109 and x are consecutive interiors, so they add to make 180.
Okay.
Good job. Any other ones?
Number 18.
Okay. Let's look at that. Okay. So if we look at number 18, What is the relationship between these two angles?
They are, I think they're alternate because they're on opposite sides.
Yeah. And they're between the parallel lines, so that means they're interior, so they're alternate interior.
Okay.
So what do we know about them?
They're congruent.
They're congruent, which means they are equal to each other, right?
Mm-hmm.
So what can you do? What problem, what equation can you write?
We know that 70 is congruent to 2y.
Okay, so how can we write that as an equation? Using an equal sign. If they're congruent, what does that mean about them?
They're the same?
They're the same. They have the same measure. So 70 equals 2y.
Okay.
So then how can we solve for y?
You divide both sides by 2.
Good. So y is equal to,
70 divided by 2 is 35.
very good. So y is equal to 35 degrees, or 35.
Okay, I think this is making sense now.
Good. So yeah, so the first thing you're looking at is what is the relationship? Are they going to be equal to each other? Am I going to have to add them together to make 180? That's what you're looking at and figuring out first based on their placement. And then once you know the placement, you can say, am I setting this equal to this? Am I having to add them together? Am I having to find a total of 180 and subtract one part to find the other? You're just figuring out how to set up your equation based on what you know about the relationship. Okay,
Okay.
very good. All righty, so I guess it's time to log out of here and log into ACT Prep.
Yes, ma'am.
All right, I'll see you in just a minute.
Okay.
Bye-bye.
Thank you.
You're welcome.